So we can construct histograms, can we interpret histograms? And that's what we're out to do. So the histogram here shows the results of a survey about the distance travelled by people to work each day. The distances were grouped in 2 kilometre intervals. Complete the table. All right, so firstly, just to get a little bit more space, complete the table. So as I said before, the area is what will now represent the frequency. So in this first one, I can see that the area is going to be 8. There's a width of 2. At the base, the class interval was 2 and the height was 4. Okay, so the base times the height would equal the frequency. And we can actually get that from our formula that we used earlier. If the frequency density equals the frequency divided by the class width, I want to rearrange this to make the frequency the subject. So that means that the frequency should equal frequency density times class width. All right, so all of this is bounded in the fact that the area represents the frequency. If you can remember that, we should be able to work through these quite nice and swiftly. So the area here, 2 times 4, I'm expecting to get an answer of 8. The area this time, let's go with the height, which is 7, and the base, which is 2. 2 times 7, I should get a frequency of 14. Okay, and that's what we see over here, frequency of 14. So 8 is verified. I've got my 14. I'm going to carry on in a similar way. Here the height was 6. Here the height was, I'll read that as a 3. And finally the height was a 2. All right. In this example, just incidentally, all of the class widths were the same. That doesn't mean it's no longer a histogram, because we're definitely using the frequency density. But just be on the lookout for different class widths, for different bases to these rectangles. But from there, I can quickly fill in exactly what's happening here. All of these frequencies added into the table. All right, once again, calculate the mean or an estimate of the mean. It's an estimate, don't forget, because we've assumed the midpoints for each of these intervals. And we assume the midpoint here to be 1, 3, 5, 7, and 9. So these are my midpoints, and the formula that is ingrained in your head by now, sum of the x values divided by the sum of the frequencies. Let me make that fx. We are working with frequencies, so the sum of the frequency times x. Right, so we're looking at 188 over 44, and just in the calculator, what does that give us? 4.27. All right, just looking once again at the diagram of the histogram, looking at the table, 4.27 seems like a reasonable estimate of the mean.